the two triangles congruent?
Yeah.
Give me the rule. What are the other rules other than that?
Side angle side.
Side angle side. Angle side angle.
Angle side.
Angle angle side. It's got to be one of those four. Sort of important to remember everything, because what we're going to do today. Name this triangle for me. Triangle on the left.
ABC.
Does it matter how you name the first triangle?
No.
So if you did this quiz, should everybody at least get that answer correct?
Yes.
Yeah, because I can't mark it wrong as long as you use the three letters A, B, and C. Now, the second one has to be matched up correctly. What's A match up to?
M.
Looking over here, A is between what markings?
1 and 2.
1 and 2. Over there it's M. What's B match up to?
H.
And what's C match up to?
F.
If angle A is 52 degrees, what other angle has to be 52 degrees?
H.
So right here we could put 52 degrees, right? If angle B is 36 degrees, what's it match up to?
H.
H. So what do we know about angle H?
36.
How can we find angle C and angle F?
Add it.
Add what?
52 and 36.
52 plus 36. Somebody help me out.
88.
Subtract that from 180. What do you get?
92.
So what's angle C?
92.
What's angle F?
92. I think I did pretty good.
Read this real quick.
Alright, did that. I guess that freaking.
Yeah, I think a kid in a wheelchair would have been more coordinated.
Probably. Are you talking about breakdancing? He's uncoordinated.
He runs like a giraffe.
No, he runs like
Cooper, quit making fun of people.
Let's go, quick.
Well, you have a more right than I do.
The quicker you get it out.
Just to give it.
We're starting right now. It's 9:10. 9:10 plus 20 minutes is out. What time?
940.
9:30. We're done at 9:30. So the quicker you get out, the quicker we get started, the more we get done. And that would help Cooper out.
A lot.
Oh, better start doing this work. Been slipping on me.
I've done the rest. It's like a first one I haven't done.
I don't believe
People
that.
already just have your mom do it again. Because he does my computer homework.
Questions?
10.
Number 10. On number 10, what's the first piece of given information tell us?
BC is parallel to EF.
BC is parallel to EF, so I'm going to mark those. Does that tell us that those two are congruent to each other?
No.
You just pulling up the book or what? There's a... Yeah, I should have another one right here to make it easier. So those two, that's not telling us that they're congruent. We said and they put two problems like this on this page. I told you that anytime you see, I can't even quit working. Anytime you see parallel, to look for what?
Alternate interior.
Alternate interior angles. The bad thing here is, are there alternate interior angles in this picture?
No.
So you got to look at the other pairs that we learned.
Smash them together.
Smash them together. When you smash them together, what kind of angles were those?
Corresponding.
Corresponding angles. So that's the other one. Alternate interior angles and corresponding angles are the two that we would normally use. All right, alternate interior angles get used a little more. This angle and this angle are going to be the corresponding angles. So what do we know about them? They're congruent. Somebody name this angle for me.
DEF.
Angle DEF. Everybody agree with Miranda on that?
Yes. Or angle E.
That one you could name angle E if you wanted to be lazy, right?
Yeah.
Name this angle for me.
CBA.
CBA. Could we name that one angle B?
No.
No, that won't work. So we know those because of corresponding angles. Somewhere in our proof we're going to put those. That's a pair of angles. Sorry. Is that enough to say the two are congruent?
No.
What's the next given say?
Segment AB is congruent to segment DE.
That's a pair of sides.
Angle C is congruent to angle F.
That's another pair of angles, isn't it?
Side angle.
Now, we got to be careful here.
Or angle
It's either got to be, since we have two pairs of angles, it's either got to be angle side or angle side angle. Which one is it?
Angle,
angle side.
Because the side's not between the two angles, so it's angle side. We should be able to write this two-column proof. What's our first statement going to be?
BC is parallel to EF.
Oops, not congruent. Parallel to ES. Is that right? That was given. As soon as we seen those two were parallel, we said what? You guys told me that we had the corresponding angles, right?
Oh, yeah.
Which angles were corresponding?
ABC and DEF.
Angle ABC is congruent to angle
E.
And if you just want to say angle E, that's fine. Our reason's just going to be like the other reason with the alternate interiors. It's going to say if parallel lines, then instead of alternate interior angles, this time what kind of angles are they?
Corresponding.
Then corresponding angles congruent. That was a pair of angles, so I put a little A out there just to help me out. Number 3. Hopefully all of you are getting this, because we are going to have a test. It's supposed to be this week, but since we had the extra day off, that messed everything up, so it'll be next week over proving these triangles congruent and stuff.
Is it gonna be on?
I'll have to check and see.
That's whenever we have your class first.
Probably.
When did test release?
Number 3, where do we go to next?
Angle C is congruent to angle F.
Angle C is congruent to angle F. Is that all right? Everybody agree with her on that?
Yes.
Yes, no, maybe? How do we know that?
Given.
Oops, that was a pair of angles. Is that enough to say the two triangles are congruent?
No.
What else?
Segment AB is congruent to segment DE.
How do we know that?
Given.
That was a pair of sides. Is that enough to say the two triangles are congruent?
Yes.
Did they already match up the triangles for us?
Yes.
That's in the proof statement, isn't it?
DEF.
The triangle ABC? Is that correct? Congruent to what triangle?
DEF.
And remember, our reason here, anytime it's two triangles, has to be one of those 4 which I erased. One of those 4. Which one is it this time?
Angle side.
Next question.
11.
Everybody have this one? Number 11.
So it's paper airplane shape.
What's the first thing they tell us?
Angle S congruent to angle U.
So let's mark those. That's a pair of angles.
Segment TR bisects angle STU.
Segment TR bisects angle STU. What's that tell you? These two angles have to be what? Congruent. So put a couple of marks on them, ignore that stray mark going up through there. So that's another pair of angles. Is that enough to say the two triangles are congruent?
Yes. Because you have the line in the middle and share.
Okay, so it shares this. So what do we know about segment RT?
It equals itself.
It's congruent to itself. Anything equals itself. Is that S between the two pairs of angles, or is it after the two pairs of angles?
Neither. It's after.
So which one are we using?
Angle
Angle side. We should be able to do this two-column proof. Statements, reasons. What's our first statement?
Angle S congruent to angle U.
How do we know that?
Given.
That was a pair of angles in the two triangles. Now what?
TR.
What is it? Segment TR bisects angle what?
STUs.
STU. How do we know that?
Given.
As soon as you hear bisects, that you're splitting something up into two. We're splitting this angle this time, so our next thing is going to be to say that whatever angles are congruent.
STR and RTU.
Make sure you're using your symbols. Angle STR is congruent to angle
RTU.
RTU. Our reason, and we're going to use the same reason over and over and over again. It's going to change a little bit if it's angles that we're bisecting, or segments, or if we're using a midpoint. This time we're bisecting an angle, so it's going to say something like, if angle bisected, ignore my poor grammar here. I know you guys want me to write in complete, total sentences, right?
No.
Right, Zach, you want everything written out completely, and if angle bisected, then split into what? Two congruent
Angles.
angles. We want to make it as short as possible just to make it easier on ourselves. Is that enough to say the two triangles are congruent?
No.
Got a pair of angles, another pair of angles.
Segment.
What was the segment that we had?
RT is congruent to RT.
Segment RT is congruent to segment RT. I'm telling you, if you don't know this property already, and I was just grading some of the quizzes that we took last time that said reflexive property. What is a reflexive property? Anything equals itself. If you don't know that, you better get it real quick. Anything equals itself. Anything equals itself as a pair of sides. Is that enough to say the two triangles are congruent?
Yes.
So now we go to the two triangles. Triangle what? What is it?
SRT.
SRT. Does it matter? They already named them for you probably, didn't they?
Yes.
What's it match up to?
URT.
All you're doing is taking this triangle, folding it down to match them up. Our reason? Easy stuff, Dylan. Easy enough that you can handle it. Because you're such an intelligent young man. Next question.
18,
What time did we say we were done?
30,
9:20?
30.
30? Really?
Sharon thought it was 9:40.
18? Is that the one we're doing next? Everybody have all that before I erase it?
Yes.
Yes? Number 18, this is sort of just like there's a problem like this on your notes today that I was going to talk about. Della came to a river during a hike, and she wanted to estimate the distance across it. She held her walking stick, segment AB, vertically on the ground at the edge of the river and sighted along the top of the stick across the river to the base of the tree. One of you guys should have read this so that it didn't take me so long to read. I'm wasting your time. Tree T. Then she turned without changing the angle of her head and sighted along the top of the stick to a rock R located on her side of the river. So after all that, you got a picture. It looks like this. So she's got this walking stick. This is all this is saying. It's one of the ways you could do this. She's standing here at the edge of the river. Hopefully she's not an idiot, right? Because she's doing this. And she sights some point on the ground going down at the edge of the river. What do we know about her walking stick in the ground right now? This is vertical, right? So it forms what kind of angles down here? Hopefully 90 degrees, right? Hopefully she's not doing this, otherwise she's not real bright. So she's looking like this and she sees some point over there. Then she turns around. Doesn't change the angle. Again, this is where she's, hopefully she's not an idiot. Because what could happen when she turns to here? That could change the angle, but also
Fall in the water.
fall in the water. She put her walking stick too close to the edge of the water, right? Hopefully she's not right on the edge and falls in the water like some idiot. So, what do we know about these two angles right here?
90 degrees.
So they're congruent to each other, right?
Yes.
She spotted something over here, I don't know. Usually you'd want to spot something like some rock, or maybe there's a frog over there on the, I don't know, whatever it is.
So frog would move.
Maybe. Hopefully, by the time you got it all set up and everything, the frog would still stay there. What else did they tell us? Anything else? What does she know about these two angles?
It should be the same.
They should be the same. That was her eyesight, right? As long as she didn't change the angle she was looking at, so they should be congruent. Anything else? What do we know about her walking stick? Did it change?
No.
So it's the same length as itself, right? Is that enough to say those two triangles are congruent?
Yeah.
So we now know that the triangles are congruent. What'd they ask us? Explain why the triangles are congruent. Why are the triangles congruent? Part A. Angle, side, angle. Good enough explanation. Part B, and this is what we're going to cover today, I think. Delma finds she has 27 paces to walk from her current location to the rock that she spotted. I think she spotted a rock over here, right? So, if this is 27 paces, guess what has to be true about the distance here that's across the river?
25.
It's gotta be 27. Those two have to be the same. And what we're gonna cover today, that's what we're gonna talk about. We're gonna prove that these two triangles are congruent. And you already know this stuff. You already know this, so this shouldn't be anything new. If these two triangles are congruent, if this orange triangle is congruent to this green triangle, and I tell you that the angle in this orange triangle right here is 90 degrees, what has to be true about the angle in this green triangle? It's got to be 90 degrees. If I tell you that this side right here in this orange triangle is 5 centimeters, how long does this side in the green triangle have to be? 5 centimeters. So those parts, any of the parts that match up, have to be congruent to each other. All right? If the two triangles are congruent. And that's what we're going to cover today. Now the bad thing with what we're going to cover today is that means our two-column proofs, when we do them, they're going to go out a step farther. Because we're going to prove the triangles are congruent, then we're going to go a step farther. So I think on this one they just asked you how far was it, right? Across the river, 27 paces. If you ever have to do any kind of, I had to take when I was in college, I had to take a surveying class. And the very first thing that we did in this surveying class was we walked the length of the football field. How long is a football field? 100 yards. If you go from goal line to goal line, it's 100 yards, 300 feet. So we walked it just at a normal pace. And then we went back and divided to figure out how much. This is what the old surveyors used to do before they had these fancy rolling tape measures and stuff where you could actually measure a bunch of stuff. You'd pace it off. And I know that my pace is exactly 3.1 feet. All right? And it's been a few years now since I graduated college. But it's 3.12 something feet. And as I went out and did actual surveying out in the county, I used that. Instead of taking a tape measure with us, we weren't allowed to use those rolling things or anything else. We had to measure things by walking paces. So, okay, I walked 5 paces, how many feet is that? And we would see how close the actual surveying was by the county. And if you ever go down to Preble County and look up something on surveying, or look up something about like your property, you'll be amazed on some of them. If you live on an old property, let's say your grandparents owned it or something, some of those properties, when you look at the deeds and stuff down at Preble County, crazy stuff. They'll say, on the northeast corner, there's a big rock. On the southeast corner, there's an oak tree. Probably not anymore, if it's been that long ago, right? And some of them, they're crazy stuff like that. Other questions? Is that all? I think we're out of time anyway. I wasted it all there, didn't I? Hang on to that. We'll do something with it here in a few minutes. Get the notes out. Fill in what you need to fill in on this. 3:30, I checked that a long time ago. 3:17 is what we're just going over. Not supposed to turn in anything yet. Is that 309 or 317?
This is 317.
Yeah. Yeah. Just lay it on top of that white box right there, and I'll get it here in a minute. These are 4 other ways to prove triangles are congruent. The only bad thing about this, these only work for what kind of triangles? It only works for right triangles. All right? I don't expect I'm not gonna put this stuff on the test. There might be something like this on the test, but you will not have to use one of these 4 ways. If you know side, 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 angle, and angle, angle, side, those are the 4 that matter. Alright? These 4 I'm showing to you because you may see them somewhere else on like the EOC test or something. Out to the side, draw this picture. Draw a right triangle. In a right triangle, you have to have what kind of angle? So mark that, label it a right angle. The 2 sides that come together to form the right angle are called the legs. So that's a leg, that's a leg. Those legs don't always have to be congruent to each other. They're not always the same. Anybody know what the 3rd side's called? That's the hypotenuse. What's always true about the hypotenuse? It's always the longest side. It's always got to be the longest. We said this at the start of this chapter. We've talked about these angles. What's true about these other 2 angles? They add up to 90 degrees, and they both have to be what kind of angles? Acute angles. Do they both have to be 45 every time? No. But they add up to 90, and they both have to be acute. The ways that we've proven triangles congruent so far: side, 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 angle, 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 side. All of them took how many pieces or how many parts? 3. These only take 2. Every year I have a couple of students that figure out, well, my 2-column proof would be 1 step shorter if I used hypotenuse leg for this certain problem. If you can do that, I'll know, and I'll give you the credit, all right? It won't be wrong. It's just, that's all it's going to make it. It's going to make it like 1 step shorter to use one of these. But they have to be right triangles. So HL stands for hypotenuse leg. If you prove the hypotenuse and these 2 triangles are congruent, and either pair of legs are congruent, then the 2 triangles have to be congruent. What do you think LL stands for? Leg, leg. Not cool, Jay. Is that too old of a joke for you guys? Is it? Nobody understood it, so I guess it's too old.
You guys don't know who L Cool J is?
Right? Apparently not.
Really?
So, if we use leg, leg, this pair of legs congruent, this pair of legs congruent. This is why we're not going to spend a whole lot of time on these. If I had these 2 triangles, and I proved those 2 sides are congruent, these other 2 sides are congruent, you got these 2 right angles here, you know all right angles are congruent. What could we use on this? Side, angle, side. And you already know that one, so why teach you something else just to add to what you have to know? So if you used LL, you might be able to make your 2-column proof 1 step shorter. If you use side, angle, side, it's going to be 1 step longer, but I think it's a little easier. What's HA stand for?
Hypotenuse angle.
Hypotenuse angle. So a pair of hypotenuse and a pair of angles. Looking at this, we got a pair of angles. The right angles are congruent. Another pair of angles and a pair of sides. We could have used which of these 4? Angle, angle, side. How about on this last one? LA, what's LA stand for? Leg angle. Angle, angle, side again, you could have used. So if you have any of these pictures, you can prove them all using one of the 4 things that we have already learned. If you'd like to use one of these, go right ahead. Again, sometimes they'll make the two-column proof a little shorter, but if you know the other ways, the only extra step that you're gonna have is you're gonna have to say that not only is this a right angle and that's a right angle, but they're congruent to each other. CPCTC. Sorry, I said it too many. We did this earlier. Find some place on your paper there that you can put this. If my pen ever starts working again. Doesn't have to be real big.
Corresponding parts.
And just write it in just like this. Corresponding. Ignore that extra mark going up through there. What's the P stand for? Parts. There's an of in here. What's this C stand for? Congruent. What's the T stand for? Triangles. Ignore that. That's triangles. And then there's an R in here. What do we know about them? They are congruent. All this is saying, this is exactly what we were saying about Delma when she figured it out. You weren't listening, were you? Should have been. When she had her two triangles that looked like this, and she figured out that the green triangle was congruent to the orange triangle, what did she know about this length and this length? They're the same. That's all this says. If we have these two triangles and they are congruent to each other, the parts that match up have to be congruent. They have to be the same. This is probably the most useful thing as far as all this stuff goes that we've learned this chapter. This is probably the most useful thing out in the real world. Because what you'd probably be doing, if I'm building something or measuring anything out in the real world, I'd try to do like Delma did there on that problem, and I wouldn't try to measure across the river. I would actually set it up so I could measure something over here on the land that's going to be equal to going across the river. I'm sure we got the Coopers of the world, who's getting on my nerves right now. Wasn't listening a second ago, then ask a silly question. Sure, there's plenty of Coopers in the world that would try to measure it some other way and then look like a unintelligent person. Do it. How could I do it that far from the board?
I am not a little fancy things.
Look. Doesn't work unless you're adjacent to the board.
Henry.
CPCTC can only be used after you've proven the two triangles congruent. So, listen closely. You still must prove the two triangles congruent. So every two-column proof that we do is still going to have this triangle is congruent to this triangle because of one of those four abbreviations. Side angle side, side side side, whatever it is. That's still got to be in there. All right? Then, if we're going a step farther than that, that next reason is going to be CPCTC. So, if I'm doing a two-column proof, and I get down here to step 5, step 6, my step 5 says the triangles, maybe it's side angle side. I know that reason 6 here has to be CPCTC. Can't be anything else. All right? So if we're doing this problem, it's got 7 statements and 7 reasons. And there was 2 pieces of given information. Even without seeing the picture and everything else, how many points should you be able to get? So there's 14 points. Should everybody get this point?
Yeah.
That's 1. How about this point?
Yeah.
That's 2. Maybe you couldn't read my writing on this, so you missed this one, you missed that one. Maybe you missed both these because, I don't know, we don't even know what they are, we can't see the picture. If you can match up the triangles, should you be able to get that one? Now, this one, you got how much? 25% chance of guessing and getting it right. Maybe you're a bad guesser and you miss it. If there's another reason after that, should anybody miss that one? It's got to be CPCTC. So there's 4 points out of 14, no matter what. And hopefully you'll be able to read the problem, so you should be able to get other points also, right? There is no place to fill this in, but there's a little space down there at the bottom of the front of the page. Write these 2 in there. Sorry, Silas, you have to write 2 whole sentences. I know, it's horrible, isn't it? Ebersole screwed up, didn't give you just, where you could just fill in a word here or there. To write a whole sentence. On Logan's first day back in class, she's writing 2 whole sentences. Her arm might fall off.
I don't think Cooper can write one.
You're left-handed.
Aren't you? So are
Yeah,
you.
same. Are you?
I ain't complaining about it.
So if we're given a problem and it looks like this, you should read the problem first every time. It says the given information, and then it says prove. If the prove statement is dealing with triangles, you will not use CPCTC anywhere in that 2-column proof. So if it's you're just proving the triangles, then we're not going to use CPCTC. When you look at the prove statement, if it says segments or angles, so if you're trying to prove segments or angles, then you will use CPCTC in your 2-column proof. So every single one of these has got some kind of pattern that you're going to go off of for your statements and reasons. And there's a certain number of points that you should be able to get every single time. Your last reason is going to be CPCTC if your proof statement has a pair of segments or a pair of angles. It's that simple. If it's just the triangles, then your last reason is going to be something like side, 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 or side, angle, side, or whatever. Don't make this harder than it is. All we're doing is adding another step to some of these proofs. This is just sort of like Delma's problem there, so we're not going to do a whole lot with it. But you can actually do this out in the real world. And I know I've done this in the past when I had to I worked with surveying for a while, and I had to do this, something sort of like this. If I take some point right here on the edge of the bank, and I look straight across at something, usually you try to find something that's over here, like a big rock or something that you know that you're right directly in line with. And you put that as point, they've marked it as point W here. I put a stake right here at B. So I put a stake at B. And then I start walking. And I walk this direction. And maybe I walk, you don't want to make it something stupid. I've seen people, when I was working with some of these surveying people, they'd walk like 32 feet, 5 3/8 inches. Why? How about we walk 100 feet? Some number that makes our math easy. What I know is right here in the middle of 100 feet. 50. So I got 50 on this side, I got 50 on this side. That's called the midpoint there, right? Then what I do, and I can't hardly draw this picture here, but I had this other point that was crossed over here. It was point W, whatever I picked to look at over there, maybe some big rock or some big tree or whatever it is. I start walking back this direction until my eyesight is exactly even with that midpoint and that tree over there, lining them up. I know this is a right angle. I know this is a right angle, so that's a pair of angles. I know this segment's congruent to this segment. That's a pair of sides. What do I know about these two angles right here in the middle? They're vertical angles, so that's another pair of angles. What do I know about those two triangles now? They're congruent. Can I figure out how far it is across that river? Do I have to? And this is where I'd get Ethan K. and James back there. I'd put them in a little boat going across the river and say, okay, one of you row the boat and the other one hold the tape measure, and I'm going to sit here on the bank and hold this end of the tape measure, and we'll measure the river. And then I could have a good laugh because you know probably with those two in the boat, what's going to happen? They're going to tip over, fall out, something, and I could laugh. The only bad thing is I got to make sure that I don't use one of my good tape measures because they're probably going to lose it when they fall out of the boat.
But you have the other end, just follow it.
Or just pull it out.
If it works that way, if it's,
Look at all those shoes.
Why would you let go of it if they let go of it?
I wouldn't let go of it.
Exactly. So you wouldn't lose it.
Yeah. I bet Cooper's dad, when he
I don't
goes,
have one.
That actually makes sense.
whenever he goes fishing with somebody, says, won't you just pull it out? And then it gets tangled all the time, I'm sure. What do you know about this distance and this distance?
It's congruent.
They got to be the same. Now, could I send Ethan and James out there to measure this and
Probably not.
not take any chance of them falling into the river?
That's pretty
I
fancy.
probably-
They probably still fall in the
They
river.
might still fall in the river.
Someone's calling. You got a phone call. Phone call.
Get out the packet.
It's her phone.
Look through it, we're gonna go through a couple of things.
Start at number 1.
Yeah.
Start with
Yeah.
I need the, this is 4 pages, I have 5.
Nick, they want you in the
4!
office.
Oh, Nick.
Yeah, we aren't gonna do it.
When am I gonna have time to write all this in?
Never. We aren't. What's that for? Right, the first page.
That one
Stupid.
song. Oh, write it out.
On the packet, first thing.
Whatever.
Got a couple of choices here. Either we can work a whole bunch of these together in the next 20 minutes, or you can sit quietly and work them by yourselves.
Let's sit quietly.
No,
No.
quiet, please. Group, or up here.
So, first thing we're going to do, looking at each one. Sorry. Looking at each one, we're going to go through and decide. And I apologize because they got stapled backwards. I don't know how that happened, but they got stapled backwards, so some of the numbers are wrong. We're going to decide whether you have to use CPCTC or not on each one. You do it however you want to. If I was doing it, I would write CPCTC next to the ones that use it and no next to the ones that don't. All right? Looking at number 1, look at the prove statement. What's the prove statement say? Angle N equals angle P. Do we use CPCTC? Yes. How do you know if you use CPCTC or not? If it's segments or angles that you're trying to prove. If it's just triangles, then no, we don't have to use it. How about number 2? Yes. Number 3. Flipping over to the back. Number 4. No. Number 5. No. Number 6. Yes, use CPCTC. 7. Which one is it? Yes. To the next page, I know it says number 11 because I got backwards. Number 11. Do we use it? 12.
Yes.
Oh, yeah.
Which one is it? Yes or no?
Yes.
Yes. 13. No. 14. Fifth, number 8. Sorry. It's on the back of the last page. No. Number 9.
No.
Number 10.
No.
Pick me out a problem.
Let's do 5.
Number 5.
Wait.
Number 5 is a good problem to do because this one, a lot of people get confused on. So you might want to watch closely. Lots of different triangles in this picture. The good thing about this one is, are we using CPCTC?
No.
So they tell you which triangles you're proving are congruent. Which 2 triangles are we proving are congruent?
FG and GFH.
So watch this. I'm going to try to trace them. F, G,
E.
I will here in a second. F, G, E. Does everybody see that triangle?
I've never seen you use anything besides for
G, F, H, because it doesn't show up very well on the board. G, F, H. Does everybody see that triangle? So we're trying to prove that those 2 triangles are congruent. The sort of purple one and the red one there. It might be helpful to you if you separate those 2 triangles. Separate off this one. What's this letter here? This letter,
G.
this letter,
E.
and then separate off the other one. What's this letter?
G. H.
What's the first thing they tell us?
Segment FH is congruent to segment G.
Segment FH. Where's segment FH at?
FH.
Here. Is congruent to segment what?
G.
Are those in our two triangles? So that's a pair of sides. Then what?
Angle HFG is congruent to angle EGF.
HFG, that's that angle right there. HFG, that's this angle, isn't it? So that's in that triangle. And it's congruent to what?
Angle EGF.
That's in this triangle, so that's a pair of angles. Is that enough to say the two triangles are congruent?
No.
What's the next given tell us? Oh, that's it. So now we gotta come up with something on our own. Last time, remember, I gave you that list of things to look for. What are some things to look for if you run out of given information?
Hypotenuse.
Vertical angles.
Leg, hypotenuse.
No, last time.
Oh.
Vertical angles is a good one. That's pretty easy to find, right? We have vertical angles right here and right here. The bad thing is, are they parts in our two triangles? No, so that wouldn't really help us this time. What else could we look for? Vertical angles is one of the really easy ones. What's the other really easy one? One that we've used so much. Alternate interior angles. If we have parallel lines, do we have parallel lines this time? They didn't tell us that, did they? So that won't help us. What's the other one that we've used over and over and over again? What if I held this up?
Anything equals.
Anything equals itself.
Oh, we have
Do we have that this time?
FG.
Does everybody see up here at the top? Do they share this side? It's a little harder to see this time because it's not like this. They sort of overlap. So we know that segment FG is congruent to what?
FG.
Segment FG. Is that enough to say the two triangles are congruent? Which one is it by? Is it by angle, side, 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 angle, side? What is it? Angle, side, angle? Side, angle, side, is that right? So should we be able to prove that these two triangles are congruent?
Yes.
What's our first statement going to be? What's our first statement?
FH is congruent to GE.
FH is congruent to GE? How do we know that?
Given.
That was a pair of sides. How about number two?
Angle HG.
Say, start over again. Angle H,
Angle HFG.
HFG is congruent to
EGF.
EGF? How do we know that? That was given?
FG is.
That was a pair of angles. And segment what?
SG is congruent to FG.
Segment FG is congruent to segment FG. How do we know that?
Anything equals itself.
Anything equals itself. That was another pair of sides. Is that enough to say the two triangles are congruent? Did they match up the triangles for us this time?
Yeah.
Yeah, so we don't have to match them up, so what did they say?
FGE is congruent to.
Slow down. FGE,
Is congruent to GFH.
GFH, triangle GFH. What's our reason?
This is.
Side angle side. Are we gonna go on and use CPCTC in this one?
No.
If we did go on, what would reason 5 be? CPCTC. But this time we don't have to because we were just trying to prove the two triangles.
Number 7.
Does everybody have that one? Yes, no, maybe?
Yes.
Which one we doing next?
7.
7?
No, we should do 4.
Number 7 looks something like this. J, K, L, P, and M, is that right? What's the first piece of given information tell us?
Angle K is congruent to angle M.
So that angle is congruent to that angle, that's a pair of angles, that's pretty easy. Then what?
Segment KL is congruent to segment M.
ML, that's a pair of sides in the two triangles.
That's it.
That's all the given?
Yep.
Now, we gotta find something on our own. What do you know about these two angles? The vertical angles, so they have to be, so mark them as congruent. That's another pair of angles. Does it go
Angle side.
angle, side, angle? Does everybody agree with Jameson on that? Is it in the right order to go angle, side, angle, or is it angle, angle, side?
Angle side.
Is the side between the two angles?
Okay.
So it's an angle, side, angle. What are we trying to prove this time?
Segment JK is congruent to segment EM.
So if we're trying to prove those, we prove the two triangles congruent first, then what do you know about those two segments?
They have to be congruent.
They have to be congruent because of
Everything else is congruent.
CPCTC.
CP, CTC. What's our first statement gonna be?
Angle K is congruent to angle
Angle K is congruent to which angle? M. How do we know that? As a pair of angles. Then what?
Segment KL is congruent to segment
Segment
ML.
KL is congruent to segment ML, is that right? How do we know that? As a pair of sides. Now, when we name these angles, can we name them with one letter?
Angle L.
Angle L.
MLP.
You gotta name it with how many letters?
Right, MLP.
So MLP, angle MLP,
JLP.
and angle JLK. How'd you know that those two angles were congruent?
Vertical angles.
Vertical angles are congruent. As a pair of angles.
That's enough.
But is that enough to say the two triangles are congruent?
Yes. Well, we're not trying
So,
to prove the triangle.
that's true, but we still have to prove them, right? So, our next step, and you have to put this step in here. Name the top triangle for me. JLK. Does it matter how you name the first triangle? No, what matters is that you match them up correctly.
So the
What's J here match up to in the other one?
P.
P. Look at them. Make sure you look at them. J doesn't have any markings in it. P doesn't have any markings in it. What's L match up to?
L.
L.
M.
And then K matches up to, not K. K matches up to M. We have to spin this triangle around to get it to match up. How do we know that those two triangles were congruent?
ASA. Angle side.
Angle, side, angle. Remember, with the triangles, anytime you're proving two triangles congruent, it's got to be one of those 4 3-letter abbreviations. Now, on this one, are we going a step farther?
Yes.
So what do we know our next reason's going to be?
CPCTC.
And it has to look this way every time. One of the 3-letter abbreviations, then CPCTC, if you're using CPCTC. This is where our proof statement comes in.
So JK is congruent to PM.
Segment JK is congruent to segment what?
PM.
PM. How many points would this be worth on the test?
10.
Now watch this. Should everybody get this point?
Yes.
Should everybody get this point?
Yes.
This one?
Yes.
This one?
Yes.
I hate to say this. Should everybody get these 2 points?
Yes.
You should be able to pick out vertical angles. If you can't pick out vertical angles, if you don't see that, hey, these are vertical angles by now, then we may have some major problems. Let's say you don't. We know that we're going to prove the 2 triangles. Should everybody be able to match up these 2 triangles? You should be able to, let's hope. Maybe, maybe not. Is everybody going to get this one?
No.
You got a 25% chance, maybe you miss it. Should you get this?
Yes.
Should everybody get this?
Yes.
Yeah, that comes from what they told you up in this proof statement. How many points you got? 70%. And that's saying that you couldn't, there were certain things that you couldn't even, with vertical angles and stuff, that you didn't have a clue. And I'm hoping that you guys are all better than that. We've got time for one more problem. 13? Does anybody notice that a lot of these pictures look the same? Is that an R?
Yeah.
Is that what it is on your paper? I can't read it on mine. What's the first thing they tell us?
S is the midpoint of QT.
So S is the midpoint of QT, this segment. What's that tell you?
Splits into 2.
So what 2 segments have to be the same?
QS and ST.
So let's mark those 2 as congruent. That's a pair of sides, right? Is that enough to say the 2 triangles are congruent? What else they tell us?
Segment QR is parallel to segment TU.
As soon as you see parallel, what should you look for?
Alternate interior angles.
Do we have alternate interior angles? So this angle, somebody name that angle for me. Angle R is congruent to angle U. So we got a pair of sides and we got a pair of angles. Is that enough to say the 2 triangles are congruent?
No.
The vertical angles,
QSR and TS.
so that angle is congruent to that angle, that's another pair of angles. Is that enough to say the 2 triangles are congruent? Yeah, what are we using?
Angle side.
Angle, angle, side. What are we trying to prove this time?
Triangle QSR.
So do we have to use CPCTC?
Nope.
So once we get to the triangles, we stop there and we're done. First statement.
S is the midpoint of QT.
That's midpoint of segment QT.
Yeah.
That was given to us. As soon as you see that you had a midpoint, what's that tell you? Midpoint does what?
Splits into
Splits into 2 congruent, 2 equal parts. Which 2 parts are equal?
2. QS and ST.
Segment QS is congruent to segment ST. Our reason, again, is that same reason we used it earlier, but it was for a bisector. It's just going to say midpoint does what? Splits segment into what? 2 congruent segments. That was a pair of sides. Is that enough to say the 2 triangles are congruent? What else?
QR is parallel to
QR parallel to
TU.
TU. That was given. Don't put an A out, or don't put an S out here beside that. We didn't say that they were congruent. We're saying they're parallel. As soon as you see parallel,
Alternate interior.
which alternate interior angles did we have?
Angle R is congruent to
Angle R is congruent to angle U. Our reason, if you have parallel lines, then what do you know? Then alternate interior angles are congruent. That was a pair of angles. Is that enough to say the two triangles are congruent? So we got a pair of sides, we got a pair of angles, what are we missing?
QSRs congruent to TS.
The vertical angles here, right? Gotta name them with 3 letters. So angle QSR, I thought I heard, is congruent to angle what?
TSU.
TSU. Not triangles, angles. How do we know that those 2 angles were congruent? Vertical angles are congruent. That's a pair of angles. Is that enough to say the 2 triangles are congruent? Were we trying to prove the 2 triangles congruent?
Yeah.
So they already matched them up for us, right?
Yeah.
So what are they?
QSR, congruent to TSU.
Triangle Q what? QSR is congruent to triangle what?
TSU.
How'd you know that those 2 triangles were congruent? Angle, angle, side. Where did we use CPCTC in this? Never, because we were just trying to prove the 2 triangles. We didn't have to go that far. Finish that up. Grab a paper towel for me so we can spray your desk.